Hi guys, my name is Jan Hollander, and this is my CIS 3367 midterm dashboard. When deciding what data I wanted to use, my first option was sports, and I looked heavily on basketball data and football data, but it was hard to find good, succinct data that wasn't already used in previous semesters. So I decided to do my project on climate change, which is a very political issue. As you can see on my dashboard, here's a Donald Trump tweet. He happens to not be in favor of policies for negating climate change, but that's neither here nor there. I found my data from Data World Bank, and when I was deciding what I wanted to make my project on, I consulted one of my friends who's actually studying the field. He's in his master's at Boston University, and he taught me something known as the Kaya identity, which is an equation that was created by a famous Japanese energy economist. And the formula goes as F being human contribution to carbon emission, and it's calculated on a country level based on population multiplied by GDP per capita multiplied by energy intensity, which is the amount of energy consumption divided by GDP, and then carbon intensity, which is your greenhouse gas emissions divided by the total energy that you're actually consuming. So if you go back to the dashboard, we can look at the dashboard a little later, but let's first look at the raw data that I scraped from the World Bank. So you see we have population of every country, GDP per capita of every country, total greenhouse gas emissions of every country, and energy use per capita of every country. And there's a fifth variable that I'll talk to later, which is connected to the dashboard, but we'll get to that later. The problem with the data that I was given was that a lot of the variables were either per capita or not per capita when they needed to be. So when I went into each individual sheet, first I grouped all of the variables into workbooks so that when I wanted to reference them on new sheets or copy them onto new sheets, I could index them simply. For example, on the GDP sheet, when I used the index function, instead of referencing raw data, which is originally where the GDP data was from, I was able to use GDP, which is the workbook that I copied from the raw data. And you can see here, these are all the cells that I didn't even need to copy the exact cells, because once I put the GDP workbook in, they already knew that from this raw data, they were able to extract the GDP. But a bigger problem I had was, for example, in total energy consumption, I had to use the index function again, but I had to create a product. So I indexed energy per capita, which is on the raw data, and then I also had to use a product, and I multiplied it by the population, which is another workbook that I created originally from the raw data. And I had to do that for energy intensity, because I had to take our total energy consumption and I had to divide it by the GDP per capita multiplied by the population to find the total GDP. And I also had to do that for carbon intensity, where I found our total greenhouse gases using the index function and then divided it by our total energy consumption. I also implemented an if-error statement, because a lot of the data for various countries were not available, and multiplying or dividing certain numbers with a 0 would give an answer that was NA, or a value, or a reference error. And that way, when you create an if-error statement and you comma NA, any value that isn't a real number will spit out NA. So that was something that was nice. It's something that cleans up the sheet. And I used that throughout the sheets where I needed to either do a multiplication or a division. And when we get into our pivot table, I first used this pivot table, and as you can see, you had to multiply my population, the GDP, the energy intensity, and the carbon intensity. And obviously I used my if-error statement so that when I didn't get a value I was looking for, it would just return 0. A lot of the problems that I had, I originally used every single country and every single year that the World Bank got, but some of the countries' data just wasn't available, and the data was spotty, and it wouldn't give me something that looked clean. So I eliminated all the countries that didn't have real data on the World Bank for the dashboard, and we ended up with 70 or so countries that have really nice data, and they really have a lot of insight. So when discussing the Kaya identity, it's more about how humans are contributing to climate change, as opposed to how much greenhouse gas emissions are we emitting. This is a real equation to kind of hone in on which countries are doing a lot of the greenhouse gas emissions and which our countries are manufacturing a lot that are creating unhealthy environments. So when you look at the dashboard, you see that I created 2 dashboards. We'll get to we'll get to the bottom, we'll get to the right pivot table a little bit later, but let's start with the left pivot table. So the left pivot table represents the Kaya identity, which is the human carbon emission, or human effect on climate change. So you can look, the graph's really nice. Something interesting is Italy, for example. Italy as a country, if you look down here, the data was only really nice from 1969 to 2010. And if you see, Italy's Kaya identity has gone down from mid-2000s till 2010, and I believe it's going to be continuing to go down. And the interesting thing about that is because Italy is a country that has had serious weather changes and is seriously in danger of the effects of climate change. Venice in specific has seen rising water levels, which is something interesting to note, that Italy as a country is actually taking dramatic steps to reduce that, because they're the ones that are feeling really what's going on. Another country that we can look at is the United States. And you can see here that the United States, while on a general level the Kaya identity had been going up, we're seeing more changes and more of a downward shift in the Kaya identity. And this is really nice, because this is showing that there are a lot of countries that have been taking dramatic steps to reduce their effects on climate change. Now we can get to the second pivot table. When I consulted my friend about, let's make this look a little bit nicer, we have only one real slicer, one pivot table. What's another variable we can use to kind of show the concrete steps that countries are taking? And that's obviously renewable energy sources. So my second pivot table was creating, my second variable that I did was countries and their electricity used from renewable sources. So that's the second slicer and the second pivot table. And if you look at Italy again here, you can see that their electricity from renewable sources has been exponentially increasing, which is very in line with they're reducing their Kaya identity. It's also a little bit biased, obviously, because more renewable energy sources have come out in the later 20th and 21st century, but it's still drastic enough to show that it's important to the countries, and